Good morning, everybody. Hopefully you guys can all hear me. Let's see, anybody here? Let's see, I'm just trying to set this up for you guys. All right, how is everybody doing this morning? I am actually here at school in the morning and just coming here because I needed to get a few things and I thought I'd check it out here. All right, so just tell me in the chat if you're here, all that kind of stuff. All right, good morning, good morning, good morning. All right, see you guys. All right, so first things first, I'm gonna go through these problems that I have here that I assigned you guys. And yes, you guys could have been able to finish the entire assignment, but I wanted to go ahead and just assign half of it for right now because I wanna make sure that we can get through all the glitches that we have in the technology, Google Classrooms, all that kind of stuff. So hopefully you guys were able to submit that stuff as you were working on it in terms of getting that homework in. If not, just, we'll work through that. All right, so let's go ahead and go through some of these problems first. So multiple choice, don't expect to see a lot of multiple choice questions on the test or quiz, but that's okay. So we're gonna go ahead and just go through these multiple choice questions. All right, number one, and if you guys have any questions, just stop me and go ahead and ask, and I'll try to explain a little bit more. Okay, so number one, and hopefully you guys can see this pretty clearly. Which of the following is a set of particles or interacting components to which energy is added or from which energy is removed? That is going to be a system. Right? That's essentially what the definition of a system is. It's just some way that we can consider what's going on and kind of just think about the system of particles. We just call that a system. Okay? Number two, an ideal gas system is maintained at a constant volume of 4 liters. If the pressure is constant, how much work is done by the system? Well, we know right away that your work in a pressure volume system in some kind of gas that's expanding or contracting, your work is equal to the pressure times the change in volume. And so if our change in volume, well, what does it say? It says we have a constant volume. If our change in volume is 0, that means the work must also be 0. So the answer is going to be A there, 0. All right, next. Which thermodynamic process takes place when work is done on or by the system, but no energy is transferred? So key here, right? No energy is transferred, right? That is called adiabatic. Right? Adiabatic. Number 4, which thermodynamic process takes place at constant volume? And right away we know constant volume, that's going to be isovolumetric. Okay, so constant volume is isovolumetric. So guys, any questions on the multiple choice so far? We will go over the other multiple choice on Monday. Again, we're just trying to take it easy today, not doing too much, making sure you guys are able to upload these into Google Classroom, and hopefully you guys are able to get all that taken care of before Monday and definitely before our quiz on Tuesday. So I don't see any questions so far, so let's go ahead and go on to the problems. Expect more of the stuff that we do on the quiz to be like the problems. And let's go ahead and try out the first problem here. All right. A container of gas is at a pressure of 3.8 times 10 to the 5th pascals. So the first thing we're going to do is just identify what our knowns and unknowns are. So we have, in this case, a pressure, and it says 3.8 times 10 to the 5th pascals, okay? And next up, it says how much work, right? So our question is, how much work is done by the gas if its volume expands by 1.8 meters cubed? And so first of all, we see that is expanding. And anytime it expands, we know that means your volume is going to be positive, and that also means that the work is going to be positive. If the gas is expanding, you have a positive delta V and a positive work. So Let's go ahead and look at see what that is. So the gas is expanding, so you have a delta V equal a positive 1.8 cubic meters. Okay? And so our equation here is that your work is your pressure times the change in volume. And we can go ahead and just plug in the numbers here. So the pressure, that's 3.8 times 10 to the 5th pascals, and your delta V, 1.8 cubic meters. Everything is nice in terms of the units, so we don't need to do any conversions for the units. And when you have pascals times cubic meters, you're going to end up with joules as your units. So let's go ahead and put this in the calculator. All right. There are a couple ways we could do this. You could simply do 3.8 times 1.8, and that's it. Hit enter, and your answer is going to be 6.84. But remember, you have this times 10 to the 5th up here, so it's going to be 6.84 times 10 to the 5th joules. Okay? Or if you're not sure exactly how to do that, just type it directly in as you have it written right here. That's 3.8 times 10 to the 5th, or 3.8 E5 times 1.8, and that's going to get us the same thing. Now, we're going to go ahead, because the number's so big, and you could write the number down like this, but we're going to go ahead and convert that to scientific notation 2. Right? We got 3 zeros, and then we got to move the decimal point 2 more spots. So once again, that's going to be 6.84 times 10 to the 5th joules. Okay, so let's pause here, and why don't you guys tell me if you have any questions so far? Or if you don't have any questions, why don't you tell me that you got it right? So tell me, did you guys get this problem right? All right, great, awesome. Not seeing your comments. Oh wait, Adam got it. That's good. Good job, Adam. Anybody else get it? Yes. All right, more people get yes. Good, good, good. Seeing a lot of people get it right. Awesome. Awesome. All right, everybody got it. That's great. Let's go ahead and do the next one. And we'll go ahead and switch this out. Okay, so next problem, we have number 2. Number 2, a cylinder has a radius. And here we go. Here's the problem down here. A cylinder has a radius. So right away, we're thinking, all right, that's going to be R. The radius is what? 0.082 meters. Now keep in mind, your radius is not your area, and your radius is not in any particular equation. But as soon as we see radius and we see cylinder, we're thinking, right, pi r squared in terms of that cross-sectional area. Okay. So we got our radius. How much work, once again, we're solving for the work, is done by a gas in the cylinder if the gas exerts a constant pressure. So we got the pressure right here. The pressure is 7.5 times 10 to the 5th pascals on the piston, moving it a distance. So it's going to be moving a distance of 0.026 meters. Okay, and so the distance is not exactly clear in the problem whether it's expanding or contracting, but the way I read it, I think it's expanding, and I think you could probably argue either way, but it appears to be expanding, so we're just going to keep everything positive in this case. Okay, so we have a radius, we have a pressure, we have a distance that is going, and we're thinking of, we want to plug it into the equation where our work equals pressure times the change in volume, but we don't know what that change in volume is. We know the pressure, but we don't know your delta V. So your area of a cylinder is going to, the volume of the cylinder is going to be the cross-sectional area times the distance that it's going to be traveling, or the height. And so let's go ahead and use that equation. So your area, cross-sectional area, is pi r squared, and your volume of a cylinder is going to be pi r squared d, or h. And so in this case, that's the distance that is moving, and so we're going to call that a change in volume, so it's going to be pi r squared d. And so let's just go ahead and plug this right back up into this equation, right? So this is your delta V, and we're going to plug it in here for that delta V. So work is your pressure times the delta V, which is pi r squared d. Okay? And so now we just plug in some numbers. We set a pressure of 7.5 times 10 to the 5th pascals. All right, and then we have pi times a radius. What is our radius again? That's 0.082 meters. And that's going to be squared. And then, sorry, running out of space here. So let's go ahead and write over here. And then that's going to be times the d value, and that's times 0.026 meters. Okay, so we can just plug this in our calculator and see what we come up with. All right, I'm seeing some more people joining us. Awesome. All well, happy studying. Awesome, awesome. All right, so let's plug this in our calculator and somewhere where we can see. Okay, so we have 7.5, and I'm going to go ahead and plug it in directly as it's written here, times 10 to the 5th times pi times 0.082 squared times 0.026, enter. And I get this number 419.9, all that kind of stuff. Let's just round it up to the nearest joule. All right, and so that's going to give us a value of, final answer of 412. And remember, the units for work, the units for energy, the units for heat is all the same. It is joules, okay? 412 joules. So, did you guys get that right? 412 joules? $412 joules. Hopefully you guys got it right. But that's it. That's all that's due for today. I know you guys probably, some of you guys have already completed the entire assignment. Right now, I just want to take this time to answer any of you guys' questions. Oh wait, somebody got 409, but maybe rounded. You probably rounded somewhere, right? And you should be rounding to somebody mentioned 2 sig figs. Yeah, your answer, technically speaking, should have 2 sig figs. And so it'd be best to round this and just say this is 410 joules. And we should round the other answer to 2 sig figs too. Yep, 409, so 410, that's fine. Probably what happened is, if you got 409, what happened is you probably, let's say maybe did part of the calculation, like you did the volume calculation, and then rounded it, and you just got 409. But perfectly fine, no problem. You get full credit for that. Okay. Any other questions? Nate, so any other specific questions? I don't get it is actually not a question. It's a statement. I hope that you get it, but any other questions? And if there aren't any questions on the problems, how about the whole Google Classroom issue? I hope you guys are able to get in Google Classroom and upload your files. And if you're having problems, make sure you talk to Mr. Vinton and all that. All right, when finding area, round the answer to 2 sig figs. Yeah, so you can, typically when you're rounding for sig figs, you round at the end. Okay, so for sig figs, yeah, that may be it. Yep. All right, so guys, other questions? Is everything working out with Google Classroom? In terms of uploading stuff, submitting stuff? When will our test be? Probably test. So we're going to try as much as possible to have quizzes and to have a somewhat of a smaller quiz or big quiz or little test or something like that. And our next one's going to be on Tuesday. Okay, and so it's going to be shorter than your normal test. It's going to be Probably, I'm thinking entirely free response. There might be a conceptual question in there somewhere, okay? But again, remember, this is going to be open notes because we're doing it at home, and I'm thinking everything is going to be just so Tuesday. So Monday is going to be our last review day. It's going to be problems like this, problems like the other ones, 3 to 5, and it's just going to be this chapter. So I'm going to make sure we have at the end of every chapter, we're not going to be combining any chapters, making any big tests. That's not going to happen at home. It's just not going to work. So what we're going to do is we're just going to have at the end of every chapter have a quiz or a little test, and the first one's going to be on Tuesday. Now the format is going to be just exactly the same way you guys are doing your homeworks. So you need to be able to, and that's part of the reason why I split this homework up into 2 parts so that you get practice of how you're going to upload these things. Okay, so back over here. From the first problem, expands means positive. What would we see for negative? Contracts. Yes, exactly. You would see contracts. You would see a volume change that is, so a final volume that's smaller, something like that. So it doesn't always say expand or contract. Sometimes, for example, let's just get rid of this. Sometimes, oops, let's just deal with this. Sometimes you might see, let's say, you can calculate an initial volume of whatever, 5.2 cubic meters, and then you have a final volume of 4.3 cubic meters, something like that. It doesn't necessarily tell you it contracts, but you see that the volume's getting smaller, okay? Or compression, so contract, compress, so the gas is compressed. That is all going to be negative delta V, which is negative work, okay? Or work, or specifically that's going to be work done, can't spell here, done on the gas. Okay? All right. Other questions? Other questions? Once again, remember that we're going to have a quiz on Tuesday. Okay? And I want to make sure that you guys are able to deal with the whole Google Classroom stuff, uploading stuff. And I know there were a significant number of problems that you guys were having. Some people saying that they couldn't upload it. Some people saying they're having this problem, that problem. It's an upload. You're not modifying the document. You're uploading. You take a picture of your stuff, or you upload the Notability file, and I'll look at that. Okay. For Google Classroom, I originally submitted an edited document of the homework, but then you posted on Google Classroom not to do that, so I tried uploading photo, but it wouldn't upload. Shoot, that's not good. If the edited document works, that's okay, but the only problem is I'm afraid that it's difficult for you guys to actually edit and write stuff down on, but it wouldn't let you upload. Has anybody had no problems uploading? Because I don't see this from your end. So has anybody been able to upload okay? And we might just need to talk with Mr. Vinton about this to try to work out any kind of kinks. So you haven't what, Monty? You haven't had any problems, or you haven't been able to upload? Haven't had any problems. Good. Okay. It's fine. Just upload a picture. Okay, great. So you guys uploading pictures, that's the way to go, hopefully. And again, since I haven't done this from your end, I don't really know what could be causing the problems. So we'll just use a picture. What format? Just like a JPEG? Or something like that. For review part 2, should we resubmit? Yeah, resubmit. That's the best way to do it. Helps me out a lot so that I can just look on that one assignment. If by chance you don't remember to resubmit, I can go back and look if I remember. But the best thing is for me to have all my part 2 homeworks in the same place. So it would really help me a lot if you could resubmit. And that would also give you guys more experience submitting, uploading to Google Classroom, because that's exactly what you're gonna have to do for the test. And I wanna make sure you guys are not gonna be using up a whole lot of time on the test day, because you're only gonna have 45 minutes to get the file, do the problems, and then upload. And I know that uploading might take you an extra 5 minutes or something like that to figure it out. So we're gonna practice this with the homework so that on the test day, we're all good. And if you're still having problems, make sure that you figure it out. Talk to Mr. Vinton. I'd love to be able to help you guys more, but I really can't, because I don't see it from your end, and I don't know exactly what the problems are. So what we're gonna do is, we're just gonna close up class from now. Are there any more physics questions? Do you want us to upload multiple copies? One for part 1. So you will have a new assignment. So don't upload multiple copies on the old assignment. I put it on fax. I don't know. I may not have added it to Google Classroom yet, but I'm going to do that in just a minute as soon as I hang up here. But yeah, so you'll get another assignment for part 2. And on that other assignment for part 2, you just upload your answers for part 2 there. Okay? Okay. So if there are no more questions, we're just going to close out here and end this here. Oh, one more question. If we did it all for Friday, should we repost? Yeah, please repost. Again, that's going to help me keep everything in the same place. And secondly, it's also going to give you guys experience 2 times of uploading stuff before we actually have a quiz, and you're timed for all this. So I'd like you guys to re-upload the part 2 on the second assignment on Google Classroom. All right, so have a great rest of your day. We are done for today's lesson, and hopefully you guys all your different classes are working out all right. Everything's going well. I miss you guys here, and hopefully you guys are being safe and all that kind of stuff. So God bless, and have a great rest of the day.